Here again, it says of the function concave up, then its first derivative gonna be a positive or equal to 0, or in case of alpha prime is increasing, its double derivative, the uh, derivative of the first derivative, it's positive or equal to 0. And the same thing to the second statement. Of the function concave down, then the second derivative can be negative or equal to 0, or of the f prime is decreasing, then the f double prime is 0 or negative. Here we have 3 examples. 3 functions of f, g, and h, and the one we want to find the sign of double prime of x. So let's take the first one. Here, notice that f is concave up function. From here, it says when it's concave up function, f double prime is positive or equal to 0. Therefore, that's our answer. For the g function, here, the function is concave down. Okay, so when it's concave down, it means the answer should be f double prime or g in case of this function equal to 0 or negative. And this function, what we can see is we have concave up this function, and then we have concave down this function. So from here, okay, the function is said to concave down. Therefore, when it's concave down, second derivative is less than or equal to 0. In this case, we have h. And for this function, this is concave up. And when it's concave up, the answer should be this. So the second derivative is larger, greater, or equal to 0. Sorry, this is h. That should be the answer. Now let's look at this example. Here we are giving this function f of x, and we want to graph the first derivative and then the second derivative. Okay, so first what we do is mark these points where the slope is 0. So if we draw a tangent line to these, slope is 0, which means the f prime will be 0 at these points. So if we draw f prime here, this point will be on the x-axis. And then from this segment here, from here to here, what we say is that the function f of x, the slope is positive. If the slope is positive, that means we have positive values of that function. Also note this point here. This point called inflection point. Inflection point is where concavity changes. So you see here, this is concave down, this is concave up. This is the inflection point. And we notice that at the inflection point is where the slope is the steepest. Here, slope is negative. So it has the highest value of negative. So what does that tell us is that slope here is positive. It's going up, so it's gonna be above the x-axis, and from here to here it's gonna be negative since the slope is decreasing. And then from this point to this point the slope is increasing. So alpha prime of x would be something similar to this function. Now let's jump to draw of double prime of x. We will use these rules here to figure out how to graph it. So for this section, what you can see, this is concave down. Alpha prime should be equal to, should be less than or equal to 0 for this. At the same time, we can think also about the first derivative here. You just apply what we apply here, but we apply it from here to graph the second derivative. So from here, what we notice first, this point here, slope is 0. That means f double prime is 0 at this point. And then what we have is that here the slope is increasing and here slope is decreasing, but these are symmetric, so the graph will be something like this. So this is, again, note that here when it's concave down, we said the value should be less than or equal to 0, which is correct. And here it's concave up, so it should be greater than or equal to 0, which is correct as well. So we can check our work multiple views using this rule in here.